Hello guys, welcome to our class for today. We are happy and excited that this is going to be the last class for this particular lecture series. Remember, we have started from the very beginning of physics, right from the introduction down to this point where we are now. Okay, so we want to appreciate all our numerous visitors, those who have visited this channel, our wonderful subscribers. We appreciate you, and please, if you have not subscribed to this channel, please subscribe to this channel. If you look at our playlist, you see that we have covered almost all the topics in your physics curriculum, and it has taken us a whole lot of work. If you look at where we started from and where we are today, we really appreciate you, and we thank God for how far He has helped us to come to this level. So we have been able to, we have done our little best, maybe not too much, but at least we have contributed our little quota to the study of physics and trying to make physics a subject that should be enjoyable to us students. We have also tried to remove the fear, right? That's why we are giving you a lot of tests to understand this question so that you can actually assess and evaluate your understanding of each of the topics and the principles that we have been able to explain to you. So please, we want positive comment from you. We want you to give us a like, give us a thumbs up. If you are just visiting and you've not subscribed, please subscribe to the channel and click on the notification bell. Invite your friends too, and tell them what you have enjoyed or what you are enjoying in YouTube. All right. If you have any challenge, please kindly reach us through the WhatsApp number that is showing on your screen, and you can also click on the WhatsApp link that is showing right under this video. Okay. So we appreciate you for your time and for being with us so far. Please, thank you so much and God bless you. Okay, so this for this particular class we are still discussing the wave particle paradox of light, and then we'll be looking at the duality of lights. Okay, so this class we are looking at the duality of lights. So please get your writing materials ready so that we can go straight to the class. Thanks. So as I've said, we're looking at the duality of light and then the Heisenberg uncertainty principle. So as we stated when we talked about the wave particle paradox, we said that the wave particle duality states that light behaves as either a wave. So we said that light behaves as either a wave or as a particle, but it cannot behave as a two at the same time. Okay, so light cannot behave as a particle and as a wave at the same time, but it can either behave as a wave or as a particle. So the Heisenberg uncertainty principle states that it is impossible to correctly locate the position of momentum of a particle at the same time. So if the electron position S is measured to a high degree of accuracy, then the simultaneous measurement of the momentum will be to a very low degree of accuracy. So it is not possible for you to be able to measure the position, or to measure the position of an electron and also the momentum accurately at the same time. No. If the position is correct, then the momentum will be less correct. And if the momentum is correct, then the position will be less correct. So according to Heisenberg principle, if delta x is the uncertainty in measuring position x, and delta p the uncertainty in measuring the momentum p, then the product of the position and the momentum, the product of the change in position and momentum is equal to or greater than the Planck's constant h. So this is what that statement says. Okay, that change in x times change in p is greater than or equal to the Planck constant. So therefore change in s will be equal to or greater than h over change in p, or change in p, which is momentum, is equal to h over change in x. Okay, so this principle can be applied to the measurement of energy of an object at a particular time t. If the uncertainty in energy is changing t and the uncertainty in time is changing t, then the principle can be represented by change in energy times change in t is greater than or equal to the Planck constant, or change in energy times change in t is greater than or equal to h all over 2 pi, as the case may be. That's okay. So this equation is very, very important, and I will also want you to please try as much as possible, because even when you go to the university, you will see through this Heisenberg uncertainty principle. Is that okay? So we use this principle now to solve some problems, and that is where we will now call it a T. All right, so let's go. Yes, guys. So this is a sample question. This one says that what is the uncertainty in the momentum of a particle if the uncertainty in position is 5.0 times 10 to the power minus 8 meters? So we have already said that the uncertainty in momentum and the uncertainty in position is greater than or equal to the Planck constant. Okay, it's greater than or equal to the Planck constant. So we can write that delta x, delta p greater than or equal to h. Alright, so what we are looking for now is what is the uncertainty momentum. So delta p greater than or equal to h all over delta x. So h is Planck constant, which is 6.6 times 10 raised to the power minus 34 all over the uncertainty in the distance, which is 5.0 times 10 raised to the power minus 8. Okay, so if you work this out, you have that uncertainty in the momentum p will be greater than or equal to 1.32 times 10 raised to the power minus 26 kilojoules meters per second. Remember, kilogram meters per second is the unit of momentum. Okay, so this is just how to solve the problem. Any periodic question that you have on this Heisenberg uncertainty principle, this is how you just solve them, right? Okay, so this is also another question. It says that the uncertainty in the velocity of a moving electron of mass 10 raised to the power 30 kg is 3 times 10 raised to the power 6 meters per second. Calculate the uncertainty of the simultaneous measurement of each position x. So Planck constant is given to you. Okay, so in this question, the mass of the electron is given to you. Mass of electron is given to you to be 10 raised to the power minus 10 raised to the power minus 30 kg. The velocity, the uncertainty, the velocity v is given to 3 times 10 raised to the power 6 meters per seconds. So you are asked to find change in x. That's what you don't know. Planck constant is given to you. Okay, so if you look at the Heisenberg uncertainty principle, change in p, which is the uncertainty in the momentum of the electron is given by change in m times v, because momentum is equals to m times v. Okay, so from this equation, h so, uh, equals to h, you will have that uncertainty in the position of the electron is greater than or equal to h all over uncertainty in momentum, and this can also be written as greater than or equal to h all over uncertainty in mass times velocity. Uncertainty in mass times velocity. Alright. So if you substitute into this equation, you have that uncertainty in position is greater than or equal to the Planck constant, which is 6 times 6 2 times 10 raised to the power minus 34 divided by the mass of the electron is 10 raised to the power minus 30, and the velocity of the electron is 3 times 10 raised to the power 6. So if you work this out with your calculator, you have that the uncertainty in position of this electron will be equals to 2.21 times 10 raised to the power minus 10 meters. Okay guys, so please work that out and then you have your answer. Okay, so that is it. Alright, so let's go straight to your test your understanding page. So these are questions that you need to use to test your understanding. The same method, the same working method, the same formula, and the same everything. Okay, so thank you so much guys, and we are so happy and excited that we are concluding that we have been able to come to this stage, and we are concluding this lecture series on this note. Thank you so much for being with us. Thank you for coming to our channel. Please help us to advertise this channel in your various social media platform, right? So if you are just visiting this channel, please subscribe to this channel, click on the notification bell, give us a like, give us a thumbs up. We are not stopping here. Okay, we will just take a little break, then we'll start with another science subject. Maybe definitely we're going to start with chemistry. Okay, so thanks so much. We are super excited that you are being with us. Continue to encourage us by giving us positive comments. We are grateful. I and my team, we are grateful and we are happy that we have contributed our little quota to the study of physics as a subject. So thank you so much, and we're also happy that God has given us the strength to do all this. So I remain Notable Michael. Please reach us through the WhatsApp number showing on your screen, and please do have a nice time, have a nice day, and say me well to all your friends and colleagues. Thank you so much, and have a good day. Thanks.